Introduction to SQL. In it, we learned about structural query language, SQL, which is a programming language for storing and processing information in a relational database. My name is Andrew Pearson, and I am the founder and managing director of Intelligentsia Limited, a software and AI consulting company based in Macau and Hong Kong. SQL is a programming language used for managing and manipulating relational databases. It is used to insert, update, and retrieve data from a database. SQL is a standard language for interacting with relational databases and is used by a wide variety of software applications and technologies. In this lesson, we will be breaking down SQL's processes and steps, including showing viewers how to use select statements, predicate operators and case expressions, string functions, working with the date and time feature, converting and cataloging, as well as joins. We will also be looking at subqueries, set operators and views, windows functions, data modifications, UDF and stored procedures, describing the commonalities and differences of the two, as well as control structures. This course also includes 3 exercises to help you get your feet wet with the tool. There's also a quiz at the end to test your knowledge on the most important aspects of SQL. Some common tasks that can be performed using SQL include creating, altering, and deleting tables and other database objects, inserting, updating, and deleting data in the table, retrieving data from one or more tables, and performing operations on the retrieved data, such as sorting, filtering, and joining data from multiple tables. SQL commands can be executed through a variety of interfaces, including command line interfaces, graphical user interfaces, and programming languages such as Python and Java. It's a powerful tool and still used widely. So I'll see you in Lesson 1. SQL, Structured Query Language, is a programming language used for managing and manipulating relational databases. It is used to insert, update, and retrieve data from a database. SQL is a standard language for interacting with relational databases and is used by a wide variety of software applications and technologies. Some common tasks that can be performed using SQL include creating, altering, and deleting tables and other database objects, inserting, update, and deleting data in a table, retrieving data from one or more tables, and performing operations on the retrieved data, such as sorting, filtering, and joining data from multiple tables. SQL commands can be executed through a variety of interfaces, including command line interfaces, graphical user interfaces, and programming languages such as Python and Java. In this lesson, we will use PostgreSQL version 11 as our database. Open pgadmin. This application is a graphical user interface-based tool to query a database. In the left pane, you can see the browser panel. Here you can see all the servers and databases you are connected to. Let's see the connection settings on this server. Right-click PostgreSQL. A pop-up will appear, then click Properties. In the Connection tab, you will see the connection settings for this server. In my case, it is a setup on my local machine, therefore the host name is localhost. It could be a local host or the configured IP address of the server or machine. In the port, it was configured as default, so it shows 5432. Maintenance database is Postgres, a default configuration as well. Username is Postgres. In my case, this is superadmin, so all the rights are given to this user. Let's go back to the browser panel, click Cancel. Expand the PostgreSQL, then enter your configured password. Expand the databases. This will show all the databases that were created in this server. We will use a database named Demo. Right-click the database demo and click the Query tool. This will open a panel on the right pane. On the upper tab, these are the tools under the Query tool. First is the Open file. If you have saved query in a text file, then you can use this button to load the query into the query window. Next is Save File. This one lets you save the query in the query window into a text file. The magnifying button is commonly used for debugging. You can use this to search a text in your query. Next button is copy. This lets you copy the selected script. The next button is paste. You can paste the copied script using this button. The next button is to delete the selected script. Alternatively, you can copy, paste, and delete using Control and C for copy, Control V or Control X for paste. Next is edit. You can insert or remove a tab and comment or uncomment a selection. Comment in the script lets the engine know that it is not part of the executable. It is just used as an informative or mark message to the user. The lightning icon is the execution button. Once clicked, this will execute the script in the middle section of the right pane. The square icon is the cancel or stop button. This will cancel the running query. Let's say you have a long-running query and need to edit or optimize the query. Just click this and it will stop any execution on the server for this particular query. The eraser icon is just to clear the query window and query history on the bottom of the query window. The last button is download as CSV. This will execute your query and download it as a CSV file. Below the Tools tab, we have the connection status bar. On the rightmost, this is the connection status. You can click to see the detailed status. Alternatively, blue icon is connected, yellow means idle, and red is disconnected. Right next to it is the description of the connection. It tells you what database you are connected to and on what server. Below the query window is the output window. Let's try to query. Open the file SQL_1_1_introduction.SQL. Then run the query by clicking the lightning button. This is just a simple query that will output one column and one record. Once the query is finished, on the Data Output tab under the Output window, you will see a table. The header of the table is the columns, and below it is the records. Let's save the output by clicking the Download button. Once the query is done, this will be saved in your default folder. In my case, it is in the Download folder. The Explain and Notifications tab will not be discussed in this lesson, as this is for a future advanced lesson. Next tab is Messages. As you can see, it says successfully run and indicated how long it runs for. Below it is the number of records. Query History tab is the queries you run for that session. Left side is the list of queries that you run, and the right side is the details of the run. One of the most basic SQL statements is the select statement, which is used to retrieve data from a database. For example, if you have a database table called customers that contains information about your customers, such as their name, address, and phone number, you can use the select statement to retrieve specific information from that table. This is the skeleton and order of a select statement. The syntax is as follows: select space column 1, comma, space column 2, comma, from space table underscore name, where space conditions, group space by space column 1, comma, space column 2, comma, having space conditions, order space by space column 1, comma, space column 2, comma. Note that select and from clauses should always be present in a select statement, where group by, having, and order by is optional depending on how you want to output the data. The select clause is used to specify the columns that you want to retrieve. You can list one or more columns separated by commas. The from clause is used to specify the table that you want to retrieve data from. Here is a sample of a simple select statement. Select space column 1, comma, space column 2, comma, space column 3, space, from, space, table underscore name, semicolon. In this example, the select statement is used to select the columns column 1, column 2, and column 3 from the table underscore name. For example, let's say you have a table called employee and you want to select the name and salary of all the employees in the table. Open pgadmin and you can use the select statement as below. Select space name, comma, space salary, space from, space employee, semicolon. This statement retrieves the name and salary of all employees in the employee table and displays it in the output. The where clause is used to filter the rows based on certain conditions. Now let's try the where clause. Let's use the current query and select only the employees who are male. Using the current query, after the table employee, type in where space gender space equals space open quotes, open single quotes, male, close single quotes, space, then run the query. This query retrieves the name and salary of all the male employees only. The group by clause is used to group the rows based on one or more columns. Let's use the same table, but let's get the number of employees per gender. We will use count, open brackets, close bracket function, to count the records. First, let's count the records per gender. Type in, select count, open brackets 1, close brackets, space, from, space, employee, space, where, space, gender, equals, open single quotes, male, close single quotes, space. Then run the query. We have 32 male employees. Now let's count the female employees. Just replace the male with female, then run the query. We have 65 female employees. We want to show in one output 32 male and 65 female. This is where the group by comes in. Select space gender, comma, count, open brackets, 1, close brackets, space, from, space, employee, space, group, space, by, space, gender. Then run the query. Now we have selected the column gender and outputted the count per gender using the group by clause. The having clause is used to filter the group based on certain conditions. Let's say I want to get the average salary for each department, but only for departments where the average salary is above $50,000. Let's use average, open brackets, close brackets, space, function to get the average salary. Type in, select space department, comma, AVG, open brackets, salary, close brackets, space, from, space, employee, space, group, space, by, space, department, space, having, space, AVG, open brackets, salary, close brackets, space, greater than, space, 50,000, semicolon. Then run the query. Now we have all the departments that have an average salary of $50,000. The order space by clause is used to sort the rows based on one or more columns. For example, I want to get all the employees sorted by date of birth in descending order. Type in, select space first underscore name, comma, last underscore name, comma, space, DOB. From space employee, order space by, space, DOB, space, DESC, semicolon. Now we have all the records of employees sorted by date of birth from youngest to oldest. Predicates are conditions that evaluate to either true or false, and they are used in SQL statements to filter, sort, or group data. Predicates are typically used in the where clause of a select, update, or delete statement to specify which rows to include or exclude based on some condition. Predicates in SQL include comparison operators, logical operators, like operators, between operator, in operator. Comparison operators are used to compare two values and return a Boolean result. This includes equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Use the following query to differentiate the following comparison operators. Select asterisk from employee where salary equals 5,816. This will return all the employees with salaries that are equal to 5,816. In this table, we only have one record with the salary of 5,816. Select asterisk from employee where gender exclamation point equals male in quotes. This will return all the records that the gender is not male. We have 65 records of employees that are not male. Select asterisks from employee where salary is greater than 6,319. This returns 39 records. This covers all of the employees with a salary that is greater than 6,319. Select asterisks from employee where salary is greater than or equal to 6,319. As you can see, we have 40 records. Since there is an additional one record that the salary is equal to 6,319. This shows the records that are less than or equal to the amount specified. Logical operators. These are used to combine multiple predicates and return a Boolean result. The following operators are and, or, and not. And this will return true if all the conditions are met, otherwise it will return false. Or this will return true if any of the conditions are met. Not, this will negate the Boolean results. Let's go to pgadmin to try the logical operators. Type in, select asterisks from employee where occupation equals data scientist in single quotes and gender equals female in single quotes with natural spacing between the words. In this example, we use the AND operator, which returns only all of the employees whose occupation is data scientist and the gender is female. Now, let's use the same query and change the AND operator to an OR operator. Select asterisks from employee where occupation equals data scientist or gender equals female, order by occupation. As you can see, we have 66 records. It shows all the female employees and one record that is male, which is a data scientist. Now, let's try the NOT operator. Type in, select asterisks from employee where not gender equals female. In single quotes, since we put the NOT operator, this will show all male employee records. Additionally, you can do a combination of AND, OR, and NOT operator depending on the criteria that is required. Like operator is used to match a string pattern against a column value. It is often used with wildcard characters such as % and underscore. % matches 0 or more characters. Underscore matches a single character. Let's go to pgadmin to explain. Select first underscore name from employee where first underscore name, like ASH percentage in quotations. Notice that it finds all employees first underscore name that starts with ash. Note that this is case sensitive. Let's try to replace the capital S with lowercase s, then run the query again. Notice that it won't return any records since the first underscore name are all in uppercase. Now let's try to find all the first names that end with Anna, replace the ash % with %Anna, then run the query. Now we have 5 records of all the first names that ends with Anna. Let's try to add % on both sides, %Anna %. Run the query. This returns all the names that have Anna in their first name. Let's try the underscore wildcard. Type in, select first underscore name, comma, last underscore name from employee whose last underscore name, like H underscore T in quotations. Then run the query. This query returns the names of employees where the first character is H and the third character is T. Let's try to add another wildcard. Replace the T with an underscore. Then run the query. Now we will get all the names of the employees with a 3-character last name that starts with an H. Between operator is used to match a range of values between two values. Let's try this in pgadmin. Type in, select first underscore name, comma, last underscore name, comma, salary from employee where salary between 5,000 and 6,000. Now we have 10 employees whose salary is ranging from $5,000 and $6,000. Between operator can also be used in date. Type in select first underscore name, comma, last underscore name, comma, DOB from employee, where DOB is between 2000-01-01 and 2002-12-31. We have 28 records with date of birth between January 1st, 2000 and December 31st, 2002. In operator is used to match a value against a list of values. In pgadmin, type in select first underscore name, comma, last underscore name, comma, occupation from employee, where occupation in sales, comma, billing in quotations. Now we've got 12 records that occupation is sales and billing. We can also use the not operator to show the opposite. Add not before the IN operator, then run the query. This will show all the employees that the occupation is not sales or billing. Operators are used to perform various operations on data, such as arithmetic operations, string operations, and date/time operations. Arithmetic operators. These are used to perform mathematical operations on numeric values. This includes plus, addition, minus, subtraction, asterisk, multiplication, / division, and percentage modulo. String operators. These are used to manipulate string values, which will be discussed in the latter part of the course. Date/time operators. These are used to manipulate date and time values, which will be discussed in the latter part of the course. A case expression is a conditional statement that returns a value based on the evaluation of one or more conditions. Basic syntax of a case expression: case, when condition 1, then result 1, when condition 2, then result 2, else default underscore result end. The case keyword starts the case expression. When keyword is followed by a condition that needs to be evaluated, if the condition is true, then the result associated with that condition is returned. Then keyword is used to specify the results that should be returned if the condition in the when clause is true. Else keyword is used to specify a default result to return if none of the conditions evaluate to true. End keyword ends the case expression. Let's try this on pgadmin. This query will provide the salary grade of the employee based on the amount of their salary. Type in select first underscore name, comma, last underscore name, comma, space, salary, comma, next line, case when salary is greater than or equal to 10,000, then grade A. Next line, when salary is greater or equal to 5,000, then grade B. Next line, when salary is greater or equal to 1,000, then grade C. Next line, else grade D, end as salary underscore grade. Next line, from employee. In this example, if the salary is greater than or equal to 10,000, then the associated salary grade is grade A. Next when clause, if the salary is between 5,000 to 9,999, then the salary grade is grade B. Next when clause, if the salary is between 1,000 to 4,999, then the salary grade is grade C. Lastly, the else clause, when the salary falls below 1,000, then the salary grade is grade D. In SQL, the process of joining two or more strings or character values into a single string value is referred to as concatenation. It is a technique for joining or combining string values. Concatenation is frequently used in SQL to build dynamic strings, such as generating custom messages or constructing complex SQL queries that depend on variable inputs. Consider the two string values good and morning as an example. We could merge these data into the string hello world using concatenation. To do this with SQL, we can use the concatenation operator pipe or the concat function. Here's an example of how to concatenate two strings using the pipe operator. Go to pgadmin. Type in, select good in single quotations, pipe, morning in single quotations as pipe underscore concatenated underscore string. Then run the query. As you can see, the two strings were merged into one. Moreover, you can combine many strings into one. On our current query after the morning enclosed in single quotes, let's add double pipe space exclamation point in single quotes. Then run the query. Now we have concatenated three strings into one string using the double pipe operator. Now let's use the concat function. Type in, select concat, open brackets, good in single quotes, comma, space, morning in single quotes, close brackets, as concat function underscore concatenated underscore string. Then run the query. Now we have concatenated the strings using the concat function. Same thing with pipe operator. We can also concatenate multiple strings. Just add comma and the word to concatenate. In one current query after the morning word enclosed in single quotes, type in comma exclamation point in single quotes. Then run the query. Now we have concatenated the strings. Keep in mind that the concat function and the pipe operator have different approaches to handle null values. While the concat function exclusively concatenates non-null values, the pipe operator will return null if any of the operands are null. As an example, let's use the employee table and filter the ID is equal to 96. This employee record has a null value in the name column. Type in select name, comma, good, space, in single quotes, pipe, morning space, in single quotes, pipe, name as, pipe underscore string, comma, concat, open brackets, good, space, in single quotes, comma, morning space, in single quotes, comma, name, close brackets, as concat underscore string from employee where ID equals 96. Then run the query. As you can see, the pipe string returns null, while the concat string returns good morning, which ignores the null value. Substring function. The substring function in PostgreSQL is used to separate a substring from a provided string. The substring function's syntax is as follows. Substring, open brackets, string, space, from, space, start underscore position, space, open square brackets, for, space, length, close square brackets, close brackets. The function takes a string as its first argument and extracts a substring starting from the specified start underscore position. The start underscore position parameter is a one-based index that specifies the position at which the substring starts. If the optimal length parameter is provided, the function will extract a substring of the specified length. If the length parameter is not provided, the function will extract all characters from the starting position to the end of the string. Go to pgadmin. Here's an example of a query that the optional length parameter is not provided. Type in select space substring, open brackets, I am the king of the world, in single quotes, space from space 10, close brackets. Then run the query. This query extracts the substring king of the world starting from the 10th position of the string, I am the king of the world. Now let's try to use the optional length parameter. Type in select space substring, open brackets, I am the king of the world, in single quotes, space from space 10, space 4, space the number 4, close brackets. Then run the query. This extracts a substring of length 4 starting from the 10th position of the string, I am the king of the world, resulting in the string king. Left function. The left function in PostgreSQL returns a substring consisting of a specified number of characters from the left side of the string. The left function has the following syntax. Left, open brackets, string, comma, space, length, close brackets. Here, string is the input string from which the substring is to be extracted, and length is an integer that specifies the number of characters to be returned from the left side of the string. For example, the following query returns the first 13 characters from the left side of the string, I am the king of the world. Type in select, space, left, open single quotes, I am the king of the world, close single quotes, comma, 13, close brackets. Then run the query. This returns a result, I am the king, which has 13 characters. It should be noted that the function will return the complete string if the length parameter is more than the length of the string. The function will return an empty string if the length parameter is negative or 0. Right function. The right function in PostgreSQL returns a substring consisting of a specified number of characters from the right side of the string. The right function has the following syntax. Right, open bracket, string, comma, space, length, close brackets. Here, string is the input string from which the substring is to be extracted, and length is an integer that specifies the number of characters to be returned from the right side of the string. Basically, the right function is just the opposite of the left function. In this example, the following query returns the last 9 characters from the right side of the string, I am the king of the world. Type in select right, open brackets, single quotes, I am the king of the world, close single quotes, comma, 9, close brackets. Then run the query. This returns a result, the world, which has 9 characters. Same thing with the left function, that the right function will return the complete string if the length parameter is more than the length of the string. The function will return an empty string if the length parameter is negative or 0. Length function. The length function in PostgreSQL returns the number of characters in a given string. The length function has the following syntax. Length, open brackets, string, close brackets. Here, string is the input string for which the length is to be calculated. Let's go to pgadmin. Using the employee table, let's count the number of characters of the name column. Type in select name dot length, open brackets, name, close brackets, space from space employee. Then run the query. Now we have retrieved all the names of the employees and the numbers of the characters of the name. Notice that we have one null record, which results to null result as well. The replace function in PostgreSQL is used to search and replace all occurrences of a string with a new one. The PostgreSQL replace function performs a case-sensitive match when searching for the substring replaced. You can use this function to replace or update outdated text, correct spelling mistakes, or fix broken strings. Its syntax is as follows. Replace, open brackets, source, comma, space, old underscore text, comma, space, new underscore text, space, close brackets. In this syntax, the source is the field or string where you want to replace the existing text. The old underscore text is the specific string that you want to find and replace. If the old underscore text appears more than once in the source, all of its occurrences will be replaced. Finally, new underscore text is the replacement string for the old underscore text. Let's use this function to replace a word on the string SQL space starter space course. In a new query window in pgadmin, type select space replace space open brackets single quotes SQL in capital letters, space, starter, space, course, close single quotes, comma, open single quotes, starter, close single quotes, comma, open single quotes, beginner, close single quotes, close brackets, semicolon. Once done, run the script and check the output. Instead of seeing SQL Starter Course, the output shows the new name SQL Beginner Course since we replaced Starter with Beginner. Next, let's try to use the replace function to replace the email domain name in the employee table. In the query window, type, select space, replace space, open brackets, email, comma, open single quotes, randatmal.com, close single quotes, comma, open single quotes, secular.org, close single quotes, close brackets, space, as space, email, space, from space, public.employee. Upon executing the script, the output will show the new email address of the employees with the new email domain name secular.org. If you wish to apply the changes permanently into the table, you can use the update query, which we will cover in the latter part of the course. PostgreSQL has the repeat function to create a sequence of a string in repetition. Its syntax is repeat in capital letters, open brackets, space, string, comma, space, count, space, close brackets, where string is the string or field to be repeated, and count is the number of times to repeat the string. If count is less than 1, the function will output an empty string. Let's use the repeat function in a basic example where we will duplicate the word hi 5 times. In pgadmin, type, select space repeat, open brackets, open single quotes, hi, space, close single quotes, comma, 5, close brackets, space as space repeat underscore greeting. Run the script once done. As we can see from the output, the repeat function generated a concatenated output of hi, which is repeated 5 times. Next, let's use the repeat function in the employee table to create a variation of the ID with zeros as prefix. In a query window, type, select space, ID, comma, space, concat, open brackets, repeat, open brackets, open single quotes, 0, close single quotes, comma, 5 dash length, open brackets, cast, open brackets, ID, space, as, space, text, close brackets, close brackets, close brackets, comma, ID, close brackets, space, from, space, employee. In this query, the repeat function is used with 3 other functions to generate a new field. Concat was used to attach the repeated zeros with the ID. The length function was also used to compare how long the row's ID was in order to get its difference from 5, which will let PostgreSQL know how many zeros to add. In addition, the cast function converts the integer ID into text to let us use the length function. This cast function will be further discussed in a separate video. For now, execute the script to generate the output. As we can see from the output, the repeat function added zeros as prefixed to the ID. If the ID only has 1 digit, it adds 40, but if it has 2, it will only add 3 zeros, and so on. Upper function is used to convert a string into uppercase. It accepts any string expression or string convertible expression and converts it to an uppercase format. In case the argument is not a string, the user must use the cast function to explicitly convert it. Its syntax is upper, open brackets, string underscore expression, close brackets. String underscore expression is the field or string to convert to uppercase. For example, let's display the employee name in uppercase. In pgadmin's query window, type select space name, comma, space upper, open brackets, name, close brackets, space from, space employee. As we can observe from the two output fields, the upper function changed the letter case of each name from title case to uppercase. The lower function is the exact opposite of the upper function, wherein it converts a string, an expression, or values in a column to lowercase. The lower function takes in value with either all uppercase or partial uppercase values or characters and converts them into lowercase of the same type. Same as upper. If the expression has a non-string value, you need to convert it first. Its syntax is lower open brackets string underscore expression close brackets. Let's use the same query from earlier and change the upper function to lower. Once done, execute the script. The data output shows that the lower function converted all characters of the column name to lowercase. Previously, we talked about upper and lowercase, but another commonly used letter case when dealing with string fields is the title case. The string function that handles this type of letter case is the init_cap function. The init_cap function converts a string expression into proper case or title case, which the first letter of each word is in uppercase and the remaining characters are in lowercase. Its syntax is as follows: init_cap, open brackets, string underscore expression, close brackets, where string underscore expression is a string field or a text expression. Let's look at how it affects the scientific underscore name column of this animal underscore names table. In a new query window, type select space scientific, comma, space init cap, open brackets, scientific, close brackets, space, from space, animal underscore names, then run. Unlike lower and upper that changed the letter case for the whole string, init_cap only applied title case or uppercased the first letter for each string separated by a space. Looking at row 1, the second name Gurza became Gurza with a capital G upon applying init_cap. But the first name Colobus still looks exactly the same since it is already in the title case format. Next, let's look at the trim function of SQL. First is rtrim. The PostgreSQL rtrim function removes all specified characters from the right-hand side of a string. The syntax is as follows: rtrim, open brackets, string, comma, space, trim underscore character, close brackets. String is the next field or text to trim from, while trim underscore character is the set of characters to be removed from the right side of the string. If no characters are provided, the rtrim function will simply trim spaces from the right-hand side of the string. Let's look at how it is applied on a simple string. Navigate to pgadmin's query window and type the script. Select in capital letters space rtrim in capital letters, open brackets, open single quotes, dash dash dash, SQL in capital letters, space, course with C in capital letters, dash dash dash, close single quotes, comma, open single quotes, dash, close single quotes, close brackets. Run the script once done. As we can see from the output, rtrim only removes characters from the right-hand side of the string. All occurrence of dashes on the right end was removed, but those from the left end were retained. Next, let's try to rtrim without using any character parameters. Type select in capital letters space rtrim in capital letters, open brackets, open single quotes, space, SQL in capital letters, space, course with C in capital letters, space, close single quotes, close brackets. Execute the script once typed. If you double-click on the data output, the spaces after the string SQL space course was trimmed out, but the leading spaces are still there. This shows that if no characters are provided in the parameter, the rtrim will remove spaces on the right end of the text. Do take note that since this is a string function, the expression or field must either be a char, varchar, or text for the function to work properly. Otherwise, you will need to convert them to a string data type first. Ltrim. Ltrim is the counterpart of the rtrim function, where it is used to remove spaces or set of characters which are matching with the trimming character from the left side or the start of a string. Its syntax is ltrim, open brackets, space, string, comma, space, trim underscore character, space, close brackets. Same with rtrim. String is the field or text to trim from, while the trim underscore character is the set of characters to be removed from the left side. If no characters are indicated, ltrim will remove spaces. Let's try it on PostgreSQL by typing select in capital letters, space, ltrim in capital letters, open brackets, open single quotes, dash, 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 SQL in capital letters, space, course with C in capital letters, dash, 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 close single quotes, comma, open single quotes, dash, close single quotes, close brackets. The function removed the dashes from the left part, but retained the characters on the right side. rtrim and ltrim are great for cleaning or removing characters in a specific direction of the text. Another way of trimming characters in PostgreSQL is the trim function. With the trim function, you can remove the longest string containing a character from the start, end, or both the start and end of a string. This means that you can apply ltrim, rtrim, or both using this function, but its syntax is just a bit longer, which is composed of trim in capital letters, open brackets, leading in capital letters, /, trailing in capital letters, /, both in capital letters, space, trim underscore character, space, from in capital letters, space, string, close brackets. In this function, you need to specify which part you want to trim first. Use leading to remove characters from the left, trailing to remove from the right, or both to remove characters from both ends of the string. Trim underscore character is the set of characters to remove. If no characters are indicated, it will trim spaces, while string is the text expression or field to trim from. Let's use it on a query by typing select trim in capital letters, open brackets, both in capital letters, space, open single quotes, dash, close single quotes, space, from in capital letters, space, open single quotes, dash, 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 SQL in capital letters, space, course with C as a capital letter, dash, 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 close single quotes, close brackets. Since we explicitly told it to trim both ends of the string, the query resulted in the text SQL space course, where dashes from both the left and right end are removed from the original text. You can make this function like an ltrim if you replace the keyword both with leading, and make it function like an rtrim if you replaced the keyword with trailing. Another handy string function in PostgreSQL is pattern matching. You can use this method to output the records that contain or match a specific pattern of characters. For example, if you wanted to get the company names in a field, you would need to filter the strings that end with a suffix of corp, ltd, or inc. One of the approaches to pattern matching is the traditional SQL-like operator. The PostgreSQL-like operator helps us to match text values against patterns using wildcards. The like expression returns true if the string is contained in the set of strings represented by pattern. Its syntax is string space like in capital letters space pattern. String is the field or text expression, while pattern is a set of strings that you want to find in the string. Like pattern matches always cover the entire string. To match a pattern anywhere within a string, the pattern must therefore start and or end with a wildcard character. PostgreSQL provides you with two wildcards. %, matches any sequence of 0 or more characters. _ matches any single character. For example, let's look at how we can apply this to the animal _ names data set. Open a new query window in PostgreSQL and type select in capital letters space asterisk space from in capital letters space animal _ names space where space common space like space in single quotes %cat. This query will find all records that end with cat as its common name. Run the script to check the output. Since we specified a % at the start of the pattern, the query looked for all common names that end with cat. Notice how the output differs once we add another % to the pattern, but place it at the end of the cat string. Run the script to see the output. The total records now include not only the strings that end with cat, but those that contain cat in the middle of their name. For example, name ID 158 that has the name Igreet, cattle was captured since it has cat in the center. The % symbol wildcard will match any sequence of characters when you use it in the pattern. But if you wanted to specify the number of characters in a pattern, you can use the _ wildcard instead. In the query window, type select in capital letters space asterisk space from in capital letters space animal _ names space where space common space like space pu __. This query will find all animals in the dataset that start with pu and followed by 2 characters. Run the script to check the output. PostgreSQL found 2 records that match the pattern, the animals Puku and Puma. Working with date and time. Another common data type used in SQL is the date and time. PostgreSQL uses 4 bytes to store a date value. The earliest possible date is 4713 BC, and the latest possible date is 5,874,897 AD. When storing a data value, PostgreSQL uses the YYY-MM-DD format, e.g. 2023-02-23 or February 23, 2023. The same format is also used for inserting data. Let's start with the now function. The built-in now function is used to get the current date and time. Its syntax is simple. Now, open brackets, close brackets. Type the same syntax to Postgres query tool and execute the script. As we can observe from the single record output, the now function displayed the complete date and time stamp as well as the time zone based on the server's clock. If you only want to display it as a date, you can apply a cast function to it by typing 2 colons and date at the end of the script. Select now, open brackets, close brackets, colon, date. Another method of showing the date is by using the current _ date function. The current _ date function is so simple that it requires no argument as follows, current _ date. To show it on PostgreSQL, type in select space current _ date semicolon. Same as the now function, the current date also showed a date stamp based on the server clock. The difference between them is that the now function has the additional ability to display the time as well as the time zone. The age function takes two timestamps as arguments, subtracts the second timestamp from the first one, and retrieves the resultant interval. The basic syntax of the age function will look like this. Age, open brackets, first underscore timestamp, comma, space, second underscore timestamp, close brackets. Let's use the current date function together with the age function to show the age of each employee from the employees table. In the query window, type, select space name, comma, space, DOB, comma, space, age, open brackets, current underscore date, comma, DOB, close brackets, space, from, space, employee. In this query, the first timestamp is set to the current date, and the second is set with the date of birth of the employee. Run the script to see the output. The data output shows the age in the last column, where the number of years, months, and days of their age has been calculated. It is important to note that if you pass a single date into the age function, then it will automatically use the current date to subtract and calculate. For example, if we shorten the last script to select space age, open brackets, DOB, close brackets, space from, space employee, the data output will still display the age compared to today's date. This function is not just applicable to a person's age. You can also utilize this to show the years of service or tenure, the number of days since a customer bought a product, and so on. Next, let's look at how to filter a range of date or time values using the between operator. You use the between operator to match a value against a range of values. The following illustrates the syntax of the between operator. Value space between space low space and space high. Value is the field that will be filtered, while low and high is the specific range of values. Both can either be a static value or a field with the same data type. If the value is greater than or equal to the low value and less than or equal to the high value, the expression returns true, otherwise it returns false. The between operator is usually used as a subquery and is used by other commands such as select, where, and from. The keyword and is always used as a separator between the range that we provide from high to low values in the PostgreSQL syntax. Let's use this operator to filter which employee logs in during 10 a.m. to 12 noon. In the query window, type, select space, first name, comma, log time, space from, space, log underscore time in, space where, space, log time, space, between, space, open single quotes, 10, colon, 00, close single quotes, space, and, space, open single quotes, 12, colon, 00, close single quotes. The resulting data is filtered based on the log time values that are greater than or equal to 10 a.m. and less than or equal to 12 noon. Next, let's look at how we can output a date based on a certain date format. To do so, we need to use the to_char function to convert the date into a string. The PostgreSQL to_char function converts a timestamp, an interval, an integer, a double precision, or a numeric value into a string. Its syntax is to_char, open brackets, expression, comma, space, format, close brackets. Where expression is the value you want to format, while format is the template that defines the output format. For example, let's display the current date with a full month name in its format. In PostgreSQL, type select space to_char, open brackets, current_date, comma, space, open single quotes, month, space, dd, comma, space, YYYY, close single quotes, close brackets. Month on the template displays the full title-cased English month name. DD displays the 2-digit day of the month, while YYYY displays the year in 4 digits. PostgreSQL will follow this template to display the date converted into a string. Run the script to view the converted output. The text reads March 27th, 2023. Same as how we built the template. Here are other common patterns you can use for the date or time template. MON, abbreviated title case, month, name, e.g. January, February, etc. Month number from 01 to 12. Day, fully title case day name. Day of the week, Sunday 1 to Saturday 7. Week of month, 1 through 5. The first week starts on the first day of the month. Week number of the year, 1 through 53. The first week starts on the first day of the year. Hour of day, 0 through 12. Minute, 0 through 59. Working with date and time, part 2. Let's continue discussing date functions. The date part function extracts a subfield from a date or time value. To apply a date part function, you need to type date_part, open brackets, open single quotes, date time, space, identifier, close single quotes, comma, space, source, close brackets. The date time identifier is the type of value that will be extracted from the source. Source would be the field or expression to extract from. The date time identifier you can use are the following: century, decade, year, month, day, hour, minute, second, microseconds, milliseconds, acronyms for date of week, DOW, DOY, epoch, ISO, DOW, ISO, YEAR, time zone _hour, time zone _minute, and week. For example, let's use the date part function to show the day of the week and day of the year based on the current date. In PostgreSQL, type select space date_part, open bracket, open single quotes, DOW, close single quotes, comma, now, open brackets, close brackets, space, as, space, DOW, comma, space, date_part, open brackets, open single quotes, DOY, close single quotes, comma, now, open brackets, space, as, space, DOY, semicolon. In this script, the source is the result of the now function, where we extracted DOW, or the day of the week, as well as DOY, or day of the year. Run the script to show the date part output. As we can see from the output window, it generates 2 double precision fields since the day is a numeric output. DOW resulted to 4, which means it's the 4th day starting from Monday, and DOY resulted to 89, which means it's the 89th day of the year starting from January 1st. A function that works exactly the same as date_part is the extract function. Its only difference is that extract complies with the SQL standard, while date_part is a Postgre-specific function. So you can use extract for other types of SQL, such as MySQL or SQL Server, but on the flip side, date_part can only be used in Postgre. The extract syntax is as follows: extract, open brackets, date time, space identifier, space from, space source, close brackets. The date time identifier you can use for the extract function is the same keywords in date part function that was mentioned earlier. So, if we simply replace the date_part with extract and replace the comma with from on the first script that we typed, select space extract, open brackets, DOW space from space now, open brackets, close brackets, space as space DOW, comma, space, extract, open brackets, DOY, space, from, space, now, open brackets, close brackets, space, as, space, DOY, semicolon. The output shown would be the same as the date part result. The date trunc function of Postgre allows the user to round off the date field to any timestamp instance. So, instead of simply cutting off a part of the value, like what date part and extract does, it rounds the date to the value based on the date time identifier. The date underscore truc syntax is date underscore trunc, open brackets, open single quotes, date time, space, identifier, close single quotes, comma, space, source, close brackets. You can use the same date time identifiers as the ones listed for date part. Source is also the field, interval, or expression that you want to truncate from. Let's use this function to truncate the login time of employees to the hour of time in. In the query window, type, select space, log time, comma, space, date underscore trunc, open brackets, open single quotes, hour, close single quotes, comma, log time, close brackets, space, from, space, log underscore time in. Here we've also shown the original log time value, which contains the time without time zone of the employee, so we can compare it to the date trunc column that will be truncated to its hours value. Run the script to show the two columns. As we can see from the output, date trunc simply displays the hour while the minute and seconds value were dropped in the resulting column, since these values of time are smaller and come after the hour value. Let's look at how this output differs if we use date trunc on a value that has a date on it. Type, select, space, date underscore trunc, open brackets, open single quotes, hour, close single quotes, comma, now, open brackets, close brackets, close brackets. Run the script once done. The now function generates a complete date timestamp, so we can observe from the output that date trunc does not drop the date and time zone, but simply truncates the value up to the hour. Same as what we've observed from the past example, the minutes and seconds were also removed or replaced with zeros. The interval data type allows you to store and manipulate a period of time in years, months, days, hours, minutes, seconds, etc. An interval value requires 16 bytes of storage size that can store a period with the allowed range from negative 178 million years to positive 178 million years. Internally, PostgreSQL stores interval values as months, days, and seconds. The months and days values are integers, while the seconds can have fractions. The following illustrates the interval type. At space interval space open square brackets space fields space close square brackets space open square brackets space open brackets p close brackets space close square brackets, where fields is the time period, while the precision p is the number of fraction digits retained in the second field, or the precision value with the allowed range is started from 0 to 6. The @ sign is also optional, so you can omit it. You can utilize interval values when doing date and time arithmetic, such as addition, multiplication, division, and subtraction in your script. For example, if you want to know the time 6 hours before the current one, you can type select space now, open brackets, close brackets, comma, space, now, open brackets, close brackets, space, dash, space, interval, space, open single quotes, 6 space hours, close single quotes, space, as, space, SIXHRSBEFORE, semicolon. In this script, we have used interval to specifically get the difference between the current time and the interval time value of 6 hours. If we run the script, we can see that the resulting column is a timestamp, which is the same data type as that of the now column, but the hours have been reduced by 6. The PostgreSQL internal values are helpful when we have to deal with date and time manipulation. It is very easy to understand as it is human readable. The make_date function allows you to create a date from its separate year, month, and day fields. Each date part is provided as an integer, and the result is returned as a date in YYYY-mm-DD format. The function syntax is make_date, open brackets, year, space, int, comma, space, month, space, int, comma, space, day, space, int, close brackets, where year, month, and day are integers representing the year, month, and day of the date. For example, let's use the function to create a date column based on the sales day, sales month, and sales year columns of the supermarket_sales table. In the query window, type select space make_date, open brackets, sales year, comma, sales month, comma, sales day, close brackets, space, from, space, supermarket_sales. The output column is the created date based on the combined values of the integer fields that separately contain the month, day, and year. Do take note that this function only accepts integer values, so you need to convert strings before feeding them into this function. An error will also be generated if the value that was indicated is not a correct date. For example, type in select space make_date, open brackets, 2023, comma, space, 13, comma, space, 19, close brackets, semicolon. Run the script once typed. As we can see, the message indicates error. Date field value out of range, 2023-13-25, SQL state 22008. This means that one or more of the integers that you have set is not valid to create a date. For this syntax, the month number is incorrect since the maximum month number in our calendar is 12. As observed from the past lessons, SQL statements can sometimes require you to mix different data types in the same expression to reach the desired output. There are different ways to convert different data types in PostgreSQL. Let's start by discussing the data type formatting functions. We've already discussed the to_char function that converts any data type to text, so let's proceed with the rest of the formatting functions. To_date function converts string literal to a date value. The following illustrates the syntax of this function. To_date, open brackets, text, comma, format, close brackets. The to_date function accepts two string arguments. The first argument, text, is the string that you want to convert to a date. The second one is the input's format. This format must match the text field's date format, or the function won't work properly. For example, in the query window, type select space to_date, open brackets, open single quotes, 2023, space APR, space 03, close single quotes, comma, open single quotes, YYYY, space MON, space DD, close single quotes, close brackets, semicolon. In this script, we've used the format to state that the input is composed of 4-digit year numbers, space, the title-cased short name of the month, space then ending in a 2-digit number that specifies the day of the month. The same date time identifiers mentioned in 1-6 working with date and time can be used on this function. Run the script to check how the to_date function output looks. As we can see from the output window, the resulting data is the exact same date, but now in a SQL date default format of 4-digit year dash 2-digit month dash 2-digit day. If you pass an invalid date string into this function, Postgre will issue an error that the date/time field value is out of range. The PostgreSQL to_timestamp function converts a string data to a date and timestamp with time zone according to the specified format. Its syntax is to_timestamp, open brackets, timestamp, comma, space, format, close brackets, where timestamp is a string that represents a timestamp value in the specified format. Same as the to_date function, you need to indicate the exact date type format of the input to make the function work. The difference between the two is that the to_timestamp includes the whole time format as well as the time zone in its result. In PostgreSQL, type in select space to_timestamp, open brackets, 04 space 03 space 23 space 14:45, close single quotes, comma, space, open single quotes, space dd space yy space hh24:mi, close single quotes, close brackets, semicolon. In this script, we've supplied the inputs format, which consists of a 2-digit month number, space, 2-digit day number, space, 2-digit year number, space, hour of day in 24-hour format, semicolon minutes. If you run the script, the resulting data shows the date and time based on the string, but is converted to a timestamp with time zone data type, where the time zone used is based on the current system time zone. When working with time, you need to be specific if you are using a 12-hour or 24-hour format, because it may cause errors. For example, if we remove the 24 on the format, it will show the error that hour 14 is invalid for the 12-hour clock. To_number function converts a character string to a numeric value. Its syntax is as follows: to_number, open brackets, string, comma, space, format, close brackets. Same as other formatting functions, the string is the input field with a string data type, while format is the argument that indicates how the input should be interpreted. The following keywords can be used in the format. These can also apply to the to_char function. 9. Numeric value with the specified number of digits. 0. Numeric value with leading zeros. Period. Decimal point. Capital D, decimal point that uses locale. Comma. Group thousands separator. FM, fill mode, which suppresses padding blanks and leading zeros. PR, negative value in angle brackets. S, sign anchored to a number that uses locale. L, currency symbol that uses locale. G, group separator that uses locale. MI, minus sign in the specified position for numbers that are less than 0. PL, plus sign in the specified position for numbers that are greater than 0. SG, plus minus sign in the specified position. RN, Roman numeral that ranges from 1 to 3999. Capital TH or little th, uppercase or lowercase ordinal number suffix. For example, let's use the to_number function to convert a money value to a number. Select to_number, open brackets, open single quotes, $, 1, 234, 567, period, 89, close single quotes, comma, space, open single quotes, L9, G999, G999, period, 99, close single quotes, close brackets, semicolon. In this script, we've specified the exact number of digits in between separators using 9. We've used L to show that there will be a currency symbol at the start of the string, and used G to let Postgre know that a group separator is used between digits. Since our input has 2 decimal places, a period 99 was added at the last part of the format. If you run this, the resulting data shows the string converted to a numeric value with 2 decimal places. If you wanted to remove the decimals, you could simply take out the period 99 in the format. The second way of converting data types is by using the cast operator. It can convert a value of one data type into another. So we are not just limited to one specific data type when using this operator. It's syntax cast space open brackets space expression space as space target underscore type space close brackets. In this syntax, expression can be a field, constant, or an expression that contains a value, while target type is the target data type to which you want to convert the results of the expression. The data underscore type can be any data type available in Postgre as long as the input does not have any conflicting characters that can affect a conversion process. For example, you need to remove decimal places if you only want to convert the output to an integer, or remove any non-numeric characters in the expression before converting it to a numeric data type. Let's use cast to convert a string to a date. Type in select space cast open brackets open single quotes DEC space 12 comma space 2023 close single quotes space as space date space close brackets semicolon. Notice that the input string is in a common date format already, so if you run the script, the resulting output is in the converted date format using the default year, month, date value of SQL. Other standard date formats that are accepted by this operator are month/day/year, month-day-year, just to name a few. But if you have a more complicated value, such as the one used on this script, select space cast, open brackets, open single quotes, 12-December, space, 2023, close single quotes, space as, space date, space close brackets, semicolon. It will show the error, invalid syntax, since the string date is not in a permissible format. In this case, you might want to use the to_date function so you can specify the exact format of the input string. A shortcut to applying the cast function is by using a colon operator. The syntax would be expression target underscore type. By using this syntax, you can shorten your script by a few characters. For example, let's use this operator to convert a string to a decimal. Type in select space open single quotes space 1234 period 56 space close single quotes decimal semicolon. Run the script once done. As you can observe, the condensed version of the cast operator converted the value to a numeric output and removed the spaces as well. Using cast is a quick way of converting data types. It makes the process less complicated and easier to memorize. But if you need to be specific in the format of the input, the formatting functions is still a good alternative for the conversion process. PostgreSQL join is used to combine columns from one or more tables based on the values of the common columns between related tables. The common columns are typically the primary key columns of the first table and foreign key columns of the second table. PostgreSQL supports the basic type of joins, which are inner join, left outer join, right outer join, and full outer join. It also has special joins such as natural join, cross join, and self join. Let's start with the basic joins first. The inner join creates a new result table by combining column values of two tables, table 1 and table 2, based upon the join predicate. The query compares each row of table 1 with each row of table 2 to find all pairs of rows which satisfy the join predicate. When the join predicate is satisfied, column values for each matched pair of rows of table 1 and table 2 are combined into a result row. As we can observe from the Venn diagram, the inner join only outputs the common records between the tables. An inner join is the most common type of join and is the default type of join. You can use inner keyword optionally. The following is the syntax of inner join. select space table1 dot column1, comma, space table2 dot column2, space from, space table1, space inner space join, space table2, space on, space table1 dot common underscore field, space equals, space table2 dot common underscore field, semicolon. To demonstrate the different types of joins, we are going to use the zoo_1 and zoo_2 table, which contains two columns, ID and animal. In these two tables, we have two common animals and four different ones. To create an inner join, type the following script. Select, next line, zoo_1 dot ID, space ID underscore A, comma. Next line, zoo_1 dot animal, space animal underscore A, comma. Next line, zoo_2 dot ID, space ID underscore B, comma. Next line, zoo_2 dot animal, space animal underscore B. Next line, from. Next line, zoo_1. Next line, inner space join, space zoo_2, space on, space zoo_1 dot animal, space equals zoo_2 dot animal, semicolon. Run the script once done. As we can see from the output, the result of the inner join resulted in two records, lion and tiger, since these are the records which areas are available on both zoo_1 and zoo_2 table. The records that are not matched will not be included in this type of join. The outer join is an extension of the inner join. SQL Standard defines three types of outer joins: left, right, and full. And PostgreSQL supports all of these. In case of the left outer join, an inner join is performed first. Then, for each row in table T1 that does not satisfy the join condition, with any row in table T2, a joined row is added with null values in columns of T2. Thus, the joined table always has at least one row for each row in T1. As we can observe from the Venn diagram, all records from the T1 or left table will be included in the output regardless if they have a matching record or not. The following is the syntax of left outer join. Select space columns, space from, space table1, space left, space outer, space join, space table2, space on, space table1 dot common underscore field, space equals, space table2 dot common underscore field, semicolon. Let's apply a left outer join in our zoo tables. In the PostgreSQL type, select, next line, zoo_1 dot ID, comma, next line, zoo_1 dot animal, comma, next line, zoo_2 dot ID, comma, next line, zoo_2 dot animal, next line, from, next line, zoo_1, next line, left space join, space zoo_2, space on, space zoo_1 dot animal, space equals, space zoo_2 dot animal, semicolon. Execute the script once done. As we can see from the output, the left outer join generated all four records from the left table. If the record has a match on the zoo_2 table, its matching records can be seen in the second ID and animal column. Records which are unique to zoo_1 table will have null records in these two columns. The right outer join works exactly the opposite to the left outer join. First, an inner join is performed. Then, for each row in table 2 that does not satisfy the join condition with any row in table 1, a joined row is added with null values in the columns of T1. This is the converse of a left join. The result table will always have a row for each row in T2. As we can see from the diagram, it outputs all of the records from the right, regardless if they have a matching record or not. The syntax of a right outer join is as follows. Select space columns space from space table1 space right space outer space join space table2 space on space table1 dot common underscore field space equals space table2 dot common underscore field semicolon. To create a right outer join, type this script in the query window. Select next line zoo underscore 1 dot id comma next line zoo underscore 1 dot animal comma next line zoo underscore 2 dot id comma next line zoo underscore 2 dot animal next line from next line zoo underscore 1 next line right space join space zoo underscore 2 space on space zoo underscore 1 dot animal space equals space zoo underscore 2 dot animal semicolon. Run the script once typed. In the data output window, all 4 records of the zoo underscore 2 table are listed. The matching records on zoo underscore 1 can also be seen in the first instance of the ID and animal column. The last type of the basic joins is the full outer join. The full outer join or full join returns a result set that contains all rows from both the left and right tables. First, an inner join is performed. Then, for each row in table T1 that does not satisfy the join condition with any row in table 2, a joined row is added with null values in columns of T2. In addition, for each row of T2 that does not satisfy the join condition with any row in T1, a joined row with null values in the columns of T1 is added. The Venn diagram shows us that it outputs all records from both tables regardless if they match or not. Its syntax is select space columns space from space table1 space full space outer space join space table2 space on space table1 dot common underscore field space equals space table2 dot common underscore field semicolon. To apply a full outer join in our zoo table, type in select next line zoo underscore 1 dot id comma next line zoo underscore 1 dot animal comma next line zoo underscore 2 dot id comma next line zoo underscore 2 dot animal next line from next line zoo underscore 1 next line full space join space zoo underscore 2 space on space zoo underscore 1 dot animal space equals space zoo underscore 2 dot animal semicolon. As we can see from the output, all records from both zoo underscore 1 and zoo underscore 2 tables are generated. All records from the zoo underscore 1 are shown in the first ID and animal column, with the 2 matching animals on zoo 2 in the consecutive columns. Since wolf and fox are not available in zoo underscore 2, the other side is null. On the other hand, panther and rhino are only available in the zoo underscore 2 table, so it is listed on the second ID and animal column, but null on the first one. In the past lesson, we've demonstrated the types of basic joins. Now let's talk about the special joins that you can use in PostgreSQL. Natural join combines 2 or more tables based on their common columns. It essentially creates a temporary table for a set of rows to work on several 2 or more tables. When you use a natural join, PostgreSQL automatically matches the columns with the same name in both tables. If the columns have different data types, PostgreSQL will perform implicit type conversions where possible. If the columns have the same name but are of different data types and cannot be implicitly converted, PostgreSQL will raise an error. A natural join syntax is select space columns space from space T1 space natural space inner or left or right, space join, space T2, semicolon. A natural join can be an inner join, left join, or right join. If you do not specify a join explicitly, e.g., inner join, left join, right join, PostgreSQL will apply the inner join by default. Let's apply a natural join on two tables, shop order and customer table. Shop order contains the order details such as the quantity, category, and amount of the order, while customer contains the customer name, state, and city. The two tables can be joined using order ID column. In a new query window, type in select space asterisk space from space customer space natural space join space shop order. The asterisk after the select clause indicates that we want to output all available columns in both tables. Note that in a natural join, we didn't have to indicate the specific joining fields because it uses an implicit join clause based on the common column. Since we have the order ID on both tables with the same data type, PostgreSQL automatically recognizes it as the field to use for the join procedure. Run the script to view the output. As we can see from the data output window, 10 columns were generated. Since we only applied a default natural join, it only shows the order IDs which were available on both shop order and customer table. One of the differences between a natural join and a basic join is the column it returns. On a basic inner join, the order ID would be generated twice, one from the customer table and the other from the shop order table. But in this natural join script, the order ID only appears once since it is a common field between the two tables. It's important to note that natural joins can be convenient, but they can also be error-prone. If the two tables being joined have columns with the same name but different meanings or data types, the natural join may not return the results you expect. In such cases, it's usually better to use an explicit join with the on clause that specifies the join condition. Unlike the other join functions, the cross join does not have a join predicate. The cross join creates a Cartesian product between two sets of data. This type of join does not maintain any relationship between the sets. Instead, it returns the result, which is the number of rows in the first table multiplied by the number of rows in the second table, meaning it combines every row of one table with every row of the other table. So, if you have 5 records on the first table and 3 records on the second table, the generated output or product would be 15 records. It is called a product because it returns every possible combination of rows between the joined sets. The following shows the syntax of a cross join. Select space columns space from space T1 space cross space join space T2 semicolon. Let's apply a cross join between two tables, students and courses. The students table has 5 records, while course has 3. Since cross join does not use a join predicate, the two tables do not need a common column for joining. To apply the cross join, type select space asterisk space from space students space cross space join space courses. Since we have 5 students and 3 courses, the resulting output contains 15 records. As we can see from the window, every possible combination of students and courses is applied. Note that because a cross join produces a Cartesian product, the resulting dataset can be very large if both tables contain many rows. Be wary of the number of records that you are cross-joining to prevent slower processing and out-of-disk errors. The last type of special join is the self-join. A self-join in PostgreSQL is a type of join operation that involves joining a table to itself. This can be useful when you need to compare rows within the same table or when you want to retrieve related data from different rows in the same table. Since there is no self-join keyword in PostgreSQL, you can use a left join, right, or inner join to self-join a table. Also, since using the same table name for comparison is not allowed in PostgreSQL, you need to use aliases to set different names of the same table during self-join. Here are the syntax of the different joins you can use for a self-join. Select space columns, next line, from space table name 1, next line, inner space join space table name 2 space on space join predicate, or select space columns, next line, from space table name 1, next line, left space join space table name 2 space on space join predicate, or select space columns, next line, from space table name 1, next line, right space join space table name 2 space on space join predicate. Let's use an inner join to apply a self-join to the employee underscore roster table, which contains the employer ID, their name, and manager's ID. We will use the self-join to match each employee to their manager. In the query window, type in select space A, period, employee name, comma, next line, B, period, employee name, space, manager name, next line, from, next line, employee underscore roster, space A, next line, inner space join, space, employee underscore roster, space B, space on, space B, period, employee ID, space, equals, space, A, period, manager ID. In this script, we've used an alias for the tables. The first employee roster is marked as A, while the second is called B. Since they also have the same column names, we've renamed the employee name from the second table as manager name, since this will show the manager employee name value based on each employee's manager ID. Run the script to see the output. As we can observe from the data output, two columns were generated: the employee name, which lists all employees that have a manager ID, and the manager name, which shows who manages the specific employee. If you want to show all employees regardless if they have an assigned manager or not, you can opt to use the left join. In this syntax, replace inner with left, then run the script. This displays John Smith under employee name, who does not have an assigned manager and is probably a top-level employee since he has two managers under him. Subquery is basically a query within a query, or we can say nested queries. The outermost query, which is the main query, is called the outer query. The inner query, which results set is used by the outer query, is the subquery. Subqueries can be used for a variety of purposes, such as filtering data based on a condition in another table, retrieving a specific set of data based on a calculation or aggregate function, or testing a condition for each row in a table. It is important to note that subqueries can impact the performance of a SQL statement, especially if the subquery returns a large amount of data or is executed multiple times within the same statement. Subqueries can be either self-contained or correlated. self-contained subquery are queries that are independent to the outer query. This subquery is executable within the inner query. There are two types of self-contained subquery: scalar subquery and multi-valued subquery. Self-contained scalar subquery is a subquery that returns a single value. For example, I want to get the details of the last employee in our employee table. If there is no subquery, first I will get the max ID from the employee table, go to pgadmin, type in select space max, open brackets ID, close brackets, space from, space employee, then run the query. We get the result of 97 as the last ID. Now that we got the max ID, we will use the result in our where clause. Type in select space asterisk space from space employee space where space ID space equals space 97. So without subquery, we're going to do it in two steps. Now let's try to do it in subquery. From the current query, delete 97 and type in open brackets select space max open brackets ID close brackets space from space employee close brackets. Then run the query. As you can see, we got the detail of the last employee using one query. As you can see, the subquery, if we run it alone, it only returns a single value, which is 97. Let's try to change the max ID to ID, then run the whole query. It returns an error since scalar subquery has to have a single value result. In this example, we tried to use a subquery in a where clause. Now let's try to use it in a select clause. Type in select space first underscore name, comma, last underscore name, comma, salary, comma, open brackets, select space average open brackets, salary, close brackets, space from, space employee, close brackets, space as, space average underscore salary, space from, space employee, then run the query. The subquery here is getting the average salary of all employees. Now we got all of the employees' salary along with the average salary of all employees. Self-contained multi-valued subquery is a subquery that returns multiple values as a single column. We will use an employee and order table for this example. Here I want to retrieve all the orders that were transacted by the sales department. In the orders table, we have the employee underscore ID column that can be linked to the employee table using the ID column. To identify which department the employees belong to, we can use the department column. Let's go to pgadmin. Type in select space order underscore ID, comma, order underscore date, comma, quantity, comma, unit underscore price, comma, total, space from space orders, space where, space employee underscore ID, space in, space, open brackets, select, space ID, space from, space employee, space where, space department, equals, open single quotes, sales, close single quotes, close brackets. Then run the query. Now we have 51 records of orders that were transacted by the sales department. Try to run the subquery alone. We have 2 employees under sales department. This is how multi-valued subquery works. It can have one or more results set from the subquery. For that example, we have used the subquery on a where clause. Now let's try to use it in a from clause. Type in select space order underscore table, period, asterisk, comma, employee, period, name, space, from, space, open brackets, select, space, order underscore ID, comma, order underscore date, comma, shipment underscore date, comma, quantity, comma, unit underscore price, comma, total, comma, employee underscore ID, space from, space orders, space where, space total, space less than sign, greater than sign, 0, close brackets, space, as, space, order underscore table, space left, space join, space employee, space on, space order underscore table, period, employee underscore ID, space equals, space employee, period ID. Then run the query. We got 146 records with orders that total value is not 0. As you can see, we have used it in a from clause, which acts as a table from the subquery. There are a lot of use cases for subqueries depending on the requirements that are needed to produce your data. Correlated subquery are subqueries that refer to column or columns from the table that appears in the outer query. This means that the subquery is dependent on the outer query and cannot be run independently. In a way, it's as if the subquery is evaluated separately for each row. For this example, we will use the query from our first example in the self-contained scalar subquery. Let's go to pgadmin. Type in select space first underscore name, comma, last underscore name, comma, salary, comma, open brackets, select space avg, open brackets, salary, close brackets, space from, space employee, close brackets, space, as space avg underscore salary, space from, space employee, then run the query. In this query, this is a self-contained query which gets all of the employees' salary and outputs the average salary of them. As you can see, all the employee records have the same average salary. Now, using the correlated query, what we will do is get the average salary of the employees per department. Our query will be select space first underscore name, comma, last underscore name, comma, salary, comma, department, comma, open brackets, select space avg, open brackets, salary, close brackets, space from, space employee, space e2, space where, space e2 period, department, space equals, space e1 period, department, close brackets, space as, space avg underscore salary, space from, space employee, space e1, space order, space by, space department. Then run the query. Now, when you check the average salary of the employees, it differs depending on the department, because we aggregate the subquery using the department of each employee. In the subquery, it refers to the department column of the outer query. For billing department, we have 6606.4 as an average salary. For the call center, we have 6259, and all the other departments have the average salary according to the department. Remember, for self-contained subquery, the subquery is executable, but for the correlated, it is not executable. Let's try to highlight the subquery and then run the query. It is having an error since it is referencing a column from the outer query, which is the department column. Exist predicate. This accepts a subquery as input and returns true if the subquery returns any rows and false otherwise. For example, the following query returns all employees which have a record from the orders table. Type in select space ID, comma, first underscore name, comma, last underscore name, comma, department, space from, space employee, space where, space exists, space, open brackets, select space asterisk, space from, space orders, space where, space employee underscore ID, space equals, space employee period ID, close brackets. Then run the query. Now we got 12 employees that initiated an order from the customer. Understanding this query, in the outer query we have employee table, and it checks the employee underscore ID in the subquery from orders table. Then all the employees in the employee table with initiated orders in the orders table were returned as a result set. This result can be done in an inner join. However, for inner join, it will join all the matched keys for both tables, but for the exist predicate ones, it gets one record that exists on that key in the subquery, and it won't check all the other records. So in conclusion, for this case, it is optimized to use exist predicate instead of an inner join. Additionally, it is not recommended to use asterisk, which checks all the columns because it will be added on the execution load. So it will affect the performance. We can use select one instead of select asterisk, since we are only checking the key if it exists. Same with the correlated query. We cannot run the subquery from an exist predicate because we are referencing a column from the outer query. Now, we have discussed the basics of the subquery. The two use cases are a bonus for you. The first one is returning previous or next value. For this example, I want to get all the orders and add the previous order underscore ID to them. Type in select space order underscore ID, comma, order underscore date, comma, quantity, comma, unit underscore price, comma, total, comma, space, open brackets, select space max, open brackets, order underscore ID, close brackets, space, from, space, orders, space, O2, space, where, space, O2, period, order underscore ID, less than, O1, period, order underscore ID, space, close brackets, space, previous, underscore order, underscore ID, space, from, space, orders, space, O1, space, order, space, by, space, order underscore ID. Then run the query. We use the max, open brackets, order underscore ID, close brackets, and we filter the order underscore ID, which is less than the current order underscore ID, to get the previous order underscore ID. As you can see, the first order underscore ID has a null, previous underscore order underscore ID. Since it is the first order, that is why previous underscore order underscore ID is null. It is almost the same with next underscore order underscore ID, and the idea is to get the minimum value from the current value. To do this, add the query between previous underscore order underscore ID and from, type in comma, space, open brackets, select, space, min, open brackets, order underscore ID, close brackets, space, from, space, orders, space, O2, space, where, space, O2, period, order underscore ID, greater than, O1, period, order underscore ID, space, close brackets, space, next underscore order underscore ID. As you can see, we use minimum, and for the comparison, we use greater than to get the next value. Now run the query. We have all the orders associated with their next and previous order underscore ID. For 1003, the previous is null and the next order ID is 1012. For order ID 1012, the previous is 1003 and the next is 1013. The second bonus is the running aggregates. Running aggregates are aggregates that accumulate values over time. Let's go to pgadmin, type in select, space, order underscore date, comma, sum, open brackets, total, close brackets, space, total, comma, open brackets, select, space, sum, open brackets, total, close brackets, space, from, space, orders, space, where, space, order underscore date is less than,
equals
O1,
period order underscore date, close brackets, space running underscore total, space from, space orders, space
O1,
space group, space by, space order underscore date, space order, space by, space order underscore date, then run the query. As you can see, the third column has a running total. For the first record, we have a running underscore total of 3433.33. Then, on the second record, we still have a running total of 3433.33 because the total for the second record is 0. On the third record, we have a running total of 9408.66 because it adds all the total from the first record to the third. Aside from using joins, we can combine data in SQL using set operators. Set operators make it easy to construct queries and filter the results of searches across multiple tables from your database. They are used to join the results of two or more select statements. PostgreSQL has 4 types of set operators: union, union-all, intersect, and except. When using set operators, all select statements must have the same number of columns. The columns used on the output are obtained from the first query. In addition, the column list data types must be implicitly convertible by Postgre, or in simple terms, the data types of the respected columns in the queries must be compatible. Postgre does not perform implicit type conversion if the corresponding columns in the queries belong to different data types. For example, if the column from the first query is a double precision and its corresponding column in the second query is set as a text, PostgreSQL will raise a type error. Other than that, it is possible to use set operators as part of subqueries, but not on select statements containing table collection expressions. Let's start by discussing union. The union operator is used to combine results from many select statements into a result set. If the result of the select statements has any duplicate rows, then those rows will not be displayed in the result set. As you can see from the Venn diagram, it takes all of the records from the specified select statements and combines them into one. Unlike join operators, which match records using a key column, union combines data by appending it on top of one another. The syntax for union is select space columns space from space table underscore expression underscore 1, next line, union, next line, select space columns space from space table underscore expression underscore 2. Let's use zoo underscore 1 and zoo underscore 2 to demonstrate the union set operator. The tables have 2 identical records, lion and tiger, and 2 unique records each. In a new query window, type, select space asterisk space from space zoo underscore 1, next line, union, next line, select space asterisk space from space zoo underscore 2, next line, order space by space ID. Run the script once done. The union set operator generated 6 records which are all unique. The duplicate lion and tiger was not shown in the output. To show them, you need to use the union all operator. Union all is used to combine the result sets of 2 or more select statements. It returns all rows from the query, and it does not remove duplicate rows between the various select statements. Union all has better performance compared to the union operator because resources are not used in filtering duplicates and sorting the results. Its syntax is select space columns space from space table expression 1. Next line, union all. Next line, select columns from table expression 2. Let's observe how this differs with union by modifying the script we've made earlier. Add all after the union operator, then run the script. The union all shows the two duplicate records which were hidden by the union operator earlier. We now have two lion records and two tigers as well. To consider it as a duplicate, all columns must have the same value. So, if a record has the same animal but a different ID, it is not considered a duplicate. The PostgreSQL intersect operator returns the intersection of two or more datasets. Each dataset is defined by a select statement. If a record exists in both datasets, it will be included in the intersect results. However, if a record exists in one dataset and not in the other, it will be omitted from the intersect results. As you can see from the Venn diagram, it only displays records that are available on both queries. The syntax for an intersect is as follows. Select space columns, space from, space table expression 1. Next line. Intersect. Next line. Select space columns, space from, space table expression 2. Let's apply the intersect on the zoo tables to get their similar records. Type in, select space asterisk space from space zoo underscore 1. Next line. Intersect. Next line. Select space asterisk space from space zoo underscore 2. Run the script once done. Two records were generated by the intersect operator since tiger and lion are available in both tables. If they have a column that does not have the same value, the record will not be shown by the intersect operator since they will be considered as different records. The except operator returns distinct rows from the first left query that are not in the amount of the second right query. As we can see from the Venn diagram, it removes the results that are shared between the tables or queries and only retains those that are unique to the first table. Records which are unique to the second table will not be included. The syntax for an except operator is select space columns space from space table expression 1. Next line. Intersect. Next line. Select space columns space from space table expression 2. Let's apply the except operator to the zoo tables and take only the unique animals in zoo underscore 1. Open a new query window and type in select space asterisk space from space zoo underscore 1. Next line. Except. Next line. Select space asterisk space from space zoo underscore 2. Next line. Order space by space ID. The two records generated by the except operator is the wolf and fox, which are unique to zoo underscore 1 table. Lion and tiger was not included since it is also available in zoo underscore 2. Another thing to note from this script is the use of the order by clause in a set operation. Even though we are using two select statements, only one order by clause can be included and must be inserted at the end of the script. This means that individual select statements cannot contain the order by clause. Sorting is based on the column that appears in the first select query only. It is recommended to sort compound queries using column positions. If you have a regular extract of data from a complicated join query that needs to be checked every day, you can store the query into a view to save time in typing the script. Instead of having to type the long script each and every time you need the data, you can simply call the view. Views are database objects that allow you to encapsulate the details of the structure of your tables. The view does not store the data, but it simply stores the query. A view is defined based on one or more tables, which are known as base tables. Because views are assigned separate permissions, you can use them to restrict table access so that the users see only specific rows or columns of a table. Views can be used in almost any place a real table can be used. Building views upon other views is not uncommon. To create a view, use the following syntax. Create space temp, space or, space temporary, space view underscore name, space as. Next line. Select space columns from space table underscore name, where space table condition. Temp or temporary keyword is optional. If it is included, the view will be created in the temporary space. Temporary views are automatically dropped at the end of the current session. Let's create a view to display the subcategory, quantity, and customer name from the shop order and customer table. In a new query window, type create space view space customer order space as. Next line. Select space S period subcategory, comma, S period quantity, comma, C period customer name, space from space shop order space S. Next line. Inner space join space customer space C space on space S period order ID equals C period order ID. Once typed, run the script. The messages window should show that we have created a new view. On the navigation bar, refresh, then click the drop-down arrow for views. The view we've created is visible in the list. You can now use a simple select statement to show the data, or click right on the view and select View/Edit Data. A window function performs a calculation across a set of table rows that are somehow related to the current row. This is comparable to the type of calculation that can be done with an aggregate function. However, window functions do not cause rows to become grouped into a single output row like non-window aggregate calls would. Instead, the rows contain their separate identities. Behind the scenes, the window function is able to access more than just the current row of the query result. Why should you use window functions? Here are some advantages. 1. Since the rows are not aggregated into one, you can work with aggregate and non-aggregate values. This lets you calculate many things in one step that would otherwise have taken multiple lines. 2. It is simple to use and read, unlike subqueries and joins. As it reduces the complexity of the script, it is a lot easier to maintain and can also help with performance issues. PostgreSQL has a sophisticated syntax for window function calls. The following illustrates the simplified version. Select space window underscore function, open brackets, argument 1, close brackets, space over, space, open brackets, partition, space by, space group field, space order, space by, space sort field, close brackets, space from, space table name, semicolon. Window functions are permitted only in the select list and the order by clause of the query. They are forbidden elsewhere, such as in group by, having, and where clauses. This is because they logically execute after the processing of those clauses. Also, window functions execute after non-window aggregate functions. This means it is valid to include an aggregate function call in the arguments of a window function, but not vice versa. In this syntax, window underscore function is the specific function to be used. Some functions accept arguments, but others don't. The partition by clause divides rows into groups or partitions to which the function is applied. For example, if you want to get the average sales by subcategory, the script should state partition by subcategory. The partition by clause is optional. By default, PostgreSQL will treat the whole result set as a single partition. Finally, the order by clause determines the order in which the window function is applied. DESC is for descending, and ASC for ascending. Let's start with our first window function, rank. The rank function assigns a rank to every row within a partition of a result set. For each partition, the rank of the first row is 1. The rank function adds the number of tied rows to the tied rank to calculate the rank of the next row, so the ranks may not be sequential. In addition, rows with the same values will get the same rank. Its syntax is rank, open parentheses, close parentheses, space over, space, open parentheses, partition, space by, space, group field, space, order, space by, space, sort field, space, ASC, or DSC, close brackets. Let's use rank to show the ranking of restaurants based on their total sales for the year 2020. In a new query window, type, select space restaurant name, comma, space sales, comma, next line, rank, open brackets, close brackets, space, over, space, open brackets, order, space, by, space, sales, space, DESC, close brackets, next line, from, space, restaurants. Once done, run the script. The rank function generates the rank column, which shows the rank of restaurants by sales in the whole dataset from 1 to 100, since we have 100 unique restaurants. Since we indicated the order to be descending, rank 1 was assigned to the restaurant with top sales. If we have duplicate values in the list, their indicated rank will be the same. But if you want to group the ranks according to a field, you need to insert a partition by clause. Let's rank the restaurants by meals served group by state. Clear the script on the query window and type. Select space restaurant name, comma, space state, comma, space meals served, comma, next line, rank, open brackets, close brackets, space, over, space, open brackets, partition, space, by, space, state, space, order, space, by, space, meals served, space, DES, close brackets, next line, from, space, restaurants. Run the query once done. Since we indicated a partition, the ranking will start from 1 once the state changes. For example, in this dataset, BOA Steakhouse was ranked 13th under California, but the restaurant after it, Timberline Steaks and Grill, was ranked first since it is the only restaurant listed under Colorado in this table. The same process is also done for other restaurants which are from different states in the rest of the list. Another thing to note when using rank function is how it handles ranking when some values are a tie. For example, in this dataset, China Live and Ichiban have the same number of meals served. As we can see from their corresponding rank elected them both in 5th place since they are tied. But since they took up 2 places, a gap can be seen from the rankings as rank 6 was removed and 7 was elected as the next rank number. If you don't want this type of gap when ranking, you should use dense_rank. The dense_rank assigns a rank to every row in each partition of a result set. Different from the rank function, the dense_rank function will always return consecutive rank values. For each partition, the dense_rank, open brackets, close brackets function returns the same rank for the rows which have the same value. Its syntax is dense_rank, open brackets, close brackets, space, over, open brackets, partition, space, by, space, group field, space, order, space, by, space, sort field, space, ASC, or DESC, close brackets. From our last script that ranks restaurants based on meals served by state, insert dense underscore before the rank function to change the ranking. As we can see from the output, China Live and Ichiban are still a tie for 5th place, but the 6th rank was not skipped. In PostgreSQL, the row_number function is used to assign a sequential integer to every row that is returned by a query. Even if there are duplicates in a table, it will still be assigned with a unique value. You can also use partition by clause with this function to assign numbers by group. Its syntax is row_number, open brackets, close brackets, space, over, space, open brackets, partition, space, by, space, group field, space, order, space, by, space, sort field, space, ASC, or DSC, close brackets. Let's create a unique ID for each restaurant in our list by using the row_number function. In a new query, type select space asterisk, comma, next line, row_number, open brackets, close brackets, space, over, space, open brackets, order, space, by, space, restaurant name, space, ASC, close brackets, next line, from, space, restaurants. Run the script once done. As we did not specify a partition by clause, the whole table is considered to be one big partition. As we can see on the row_number column, The row numbers were assigned 1 up to 100 for each restaurant. The restaurant that starts with numbers and the letter A come first in the list since we ordered it by restaurant name. The PostgreSQL end-tile function allows you to divide ordered rows in the partition into a specified number of ranked groups as equal size as possible. These ranked groups are called buckets. The end-tile function assigns each group a bucket number starting from 1. For each row in a group, the end-tile function assigns a bucket number representing the group to which the row belongs. The syntax of the function is as follows. End-tile, open brackets, buckets, close brackets, space, over, space, open brackets, partition, space by, space, group field, space, order, space by, space, sort field, space, ASC or DESC, close brackets. For this window function, we need to specify an argument called buckets. It will represent the number of ranked groups. The buckets can be a number or an expression that evaluates to a positive integer value greater than 0 for each partition. The value must not be nullable. Note that if the number of rows is not divisible by the buckets, the end-tile function returns groups of 2 sizes with a difference by 1. The bigger groups always come before the smaller groups in the order specified by the order by clause. For example, if we are using end-tile to group a table with 5 records into 3 buckets, the first 2 groups will have 2 records, while the last or third group will only have 1 assigned record. Let's use end-tile to create 3 groups in our restaurant lists based on their sales. So type in select space restaurant name, comma, sales, comma, next line, end-tile, open brackets, 3, close brackets, space, over, space, open brackets, order, space by, space, sales, space, DESC, close brackets, space, sales group, next line, from, space, restaurants. In the data output, we can see the end-tile grouping in the last column called sales group. The order was based on sales, so top earning restaurants are on top and are assigned to the first bucket. The first bucket has a total of 34 records, while the second and third bucket both have 33 records each. We can now use this sales group to check which restaurants have high sales, average sales, or low sales.
DML stands for Data Manipulation Language, and it is a subset of SQL that is specifically used for manipulating data within a database. Data modification tasks, including inserting, updating, deleting, and retrieving data from database tables, are generally handled by DML commands. There are 3 primary DML statements: insert, update, and delete. The insert statement is used to add new rows of data into a table. It allows you to specify the values for each column explicitly or select values from another table. Syntax is insert space into space table underscore name space open brackets column 1 comma space column 2 close brackets. Next line, values space open brackets value 1 comma space value 2 close brackets semicolon. Let's go to pgadmin and type in insert space into space employee space open brackets ID comma space first underscore name comma space last underscore name close brackets. Next line, values space open brackets 1001 comma space open single quotes John close single quotes comma space open single quotes DOE close single quotes close brackets semicolon. Then run the query. Now we have inserted 1 record. Let's verify the inserted record. Type in select space asterisk space from space employee space where space ID space equals space 1001. Then run the query. As you can see, the inserted record has a value in fields ID, first underscore name, and last underscore name, and all other columns are null because in the insert query we didn't specify the other columns. The columns beside the table name in parentheses should match the number of values. If the number of columns and values do not match, there will be an error. Let's try it. So type in insert space into space employee space open brackets ID, comma, space, first underscore name, comma, space, last underscore name, close brackets. Next line, values, space, open brackets, 1002, comma, space, open single quotes, John 2, close single quotes, comma, space, open single quotes, Doe 2, close single quotes, comma, open single quotes, male, close single quotes, close brackets, semicolon. Then run the query. As expected, the query will have an error since the values do not match with the number of columns specified. We can also insert multiple records in one insert statement. In this example, we will insert 2 records. Type in insert space into space employee space open brackets ID, comma, space, first underscore name, comma, space, last underscore name, close brackets. Next line, values, space, open brackets, 1002, comma, space, open single quotes, John 2, close single quotes, comma, space, open single quotes, Doe 2, close single quotes, close brackets. Next line, comma, open brackets, 1003, comma, space, open single quotes, Mary, close single quotes, comma, space, open single quotes, Lamb, close single quotes, close brackets, semicolon. Then run the query. Now we have inserted the 2 records. If you need to add more records, then just add comma and the values after the values in parentheses. In this query, the first record is ID 1002 and the second record is ID 1003. Another way to insert is using a select statement. In this query, we will insert the record from the table temp underscore employee. This table contains the employee records. The table has 1 record. Type in insert space into space employee space open brackets space ID, comma, space name, comma, space first underscore name, comma, space last underscore name, comma, gender, comma, space email, comma, space phone, comma, space occupation, comma, space salary, comma, space marital underscore status, comma, space DOB, comma, space department, close brackets. Next line, select space ID, comma, space name, comma, space first underscore name, comma, space last underscore name, comma, space gender, comma, space email, comma, space phone, comma, space occupation, comma, space salary, comma, space marital underscore status, comma, space DOB, comma, space department, space from, space temp underscore employee. Then run the query. Now we have inserted 1 record from the temp underscore employee table to the employee table. The update statement is used to modify the values of 1 or more columns in existing rows of a table. It allows you to update the data based on specified conditions. The syntax is update space table underscore name, next line, set space column 1 space equals space value 1, comma, space column 2 space equal sign space value 2, next line, where space condition, semicolon. Let's check the employee ID 1003. Type in select space asterisk space from space employee space where space ID space equals space 1003. As you can see, there are several fields that are null. Let's try to fill in the null fields using this statement. Type in update space employee, next line, set space name space equals sign space open single quotes Mary space Lamb close single quotes comma space gender space equal sign space open single quotes female close single quotes comma space email space =, space, open single quotes, mlam@demo.com, close single quotes, comma, space, phone, space, equals, space, open single quotes, 1111, close single quotes, comma, space, occupation, space, =, space, open single quotes, analyst, close single quotes, comma, space, salary, equals, space, 8200, comma, space, marital _ status, =, open single quotes, single, close single quotes, comma, space, DOB, space, =, space, open single quotes, 1990-01-01, close single quotes, comma, space, department, equals, open single quotes, IT, close single quotes. Next line, where space, ID, space, equals 1003. Then run the query. Let's run the selected query again to check the values to see if it was updated. The employee with ID 1003 now has values in all of the fields. Note that we can use a where clause to identify which record will be updated. If we don't use such a where clause, then all of the records will be updated. The delete statement is used to remove one or more rows from a table. It allows you to specify conditions to determine which rows should be deleted. Syntax: delete space from space table _ name, where space condition, semicolon. For this example, we will delete the employee with ID 1004. Type in delete space from space employee space where space ID space equals 1004, semicolon. Then run the query. Now we have deleted one record, which is ID 1004. Same thing with the update. If there is no where clause, then all of the records will be deleted. The truncate statement is used to remove all rows from a table, effectively deleting all the data within that table. Unlike the delete statement, which removes rows one by one, truncate is a more efficient and faster operation for removing all data from a table. The syntax is truncate space table _ name, semicolon. Please take note that truncate is a DDL, data definition language statement, not a DML, data manipulation language statement. This means that it is used for defining or altering the structure of database objects rather than manipulating the data itself. Aside from using data from fields in a table, we can also utilize PL/PGSQL to enhance the capabilities of our PostgreSQL database system. PL/PGSQL, or Procedural Language / PostgreSQL, is a procedural programming language where you can perform more intricate processes compared to the usual SQL functions, and make use of loops, functions, and triggers. PL/PGSQL was designed to create user-defined functions, stored procedures, and triggers, extend standard SQL by adding control structures such as if, case, and loop statements, inherit all user-defined functions, operators, and types. PL/PGSQL code is managed in blocks, block-structured code, into which anonymous blocks, functions, and procedures are organized. The syntax of a block structure is as follows: less than sign, label name, greater than sign, next line, declare, next line, declarations, next line, begin, next line, statements, next line, exception, next line, exception handler, next line, end, space, label name, semicolon. In this structure, the block consists of two sections, declaration and body. The declaration section is optional. This is where we can state all the variables that we can use in the begin section. The begin section is required, however. This is where we can apply actions such as calculations, loops, functions, procedures, etc. Do note that each statement in these sections is also terminated by a semicolon. The exception section, which is optional as well, is where you can insert handles for catching errors during runtime. The start and end part of the block also has an optional label name. You use the block label name in case you want to specify it in the exit statement of the block body, or if you want to qualify the names of variables declared in the block. After all of those sections, a block is then ended with a semicolon after the end keyword. Let's start by creating a simple anonymous block. Type in do space $, next line, less than sign, sample underscore block 1, greater than sign, next line, declare, next line, enrollees space integer space colon equals space 0 semicolon. Next line, begin, next line, select space count, open brackets, asterisk, close brackets, next line, into space enrollees, next line, from space students, semicolon, space, space, raise space notice space, single quotes, the space number space of space enrollees space is space %, close single quotes, comma, space enrollees, semicolon. Next line, end space sample underscore block 1 space $, semicolon. The block starts with a do statement which executes an anonymous code block, or in other words, a transient anonymous function in a procedural language. The code block is treated as though it were the body of a function with no parameters, returning void. It is parsed and executed a single time. It is important to remember that the do statement is not a part of the block, but it is used to execute the block itself. Since we indicated a $quoted string in the do statement, this makes the block code a lot simpler rather than having to surround the whole block in a single quote. The $$ is a substitution of a single quote. This is what the normal code would look like if the $quote was not included. If you follow the normal method, you also need to escape every single quote and backslash, which would be tedious. Back to our sample code block, the declaration section contains the variable called enrollees, which is defaulted as 0. Then, in the begin section, we use a simple SQL select statement in order to get the total number of records listed inside the table students and place it into the enrollees variable. Finally, we use the raise notice function to display the text, the number of enrollees is, plus the value of the created variable. If you run this code, the messages window returns notice. The messages window returns notice. The number of enrollees is 5, which is correct since we only have 5 students recorded in our table. To dive deeper with PL/PGSQL, we will talk about each section of a code block one by one, starting with the declaration. In PostgreSQL, a variable assigns a specific name to a memory location whose value can be changed. This means that data can be temporarily stored in variables during code execution. The variable always has a particular data type given to it. The PostgreSQL variable's value can be modified using a function or code block. If no values are set by default, the variable's value will be initialized as null. In order to use a variable, it must be declared first. Consider the following syntax to declare a variable. Declare space var underscore name space constant space data dash type space not space null space default space initial underscore value semicolon. In this syntax, var underscore name is the variable name you want to assign. Constant is an optional component. When defined, we cannot change the variable's value once the variable has been initialized. Data-type would be the assigned data type of the variable, such as Boolean, date, text, etc. Not null is an optional parameter. that makes sure that the variable must contain a non-null value. The default keyword initializes the given variable with a default or initial value. As stated earlier, the default value is optional. Each statement in the declaration section is terminated with a semicolon. Now that we have an idea on how a block-structured code works, let's move to the control structures that we can apply in the begin section of our PL/PG/SQL code. Control structures are a block of code that evaluates variables and then performs certain instructions in a specific way based on the given parameters. Using this type of structure, you can manipulate PostgreSQL data in a very flexible and powerful way. In this lesson, we're going to discuss two types of control structure, conditional and looping. Conditional control structures let you execute alternative commands based on certain conditions. For example, you can use it to generate a specific string to determine if your sales are low or if they exceed the quota. The process will start once the total sales amount needs to be generated. Then it will be tested against the condition sales less than 100,000. If the sales meet the condition, we will return the text sales are below KPI. But if it does not, it will text for the second condition sales equal 100,000 if the sales match the exact KPI amount. The text will show sales reached the exact KPI. But if it still fails the second condition, it will go straight to the default statement, which displays sales exceed KPI. Conditional structures make it easier for us to apply specific statements or processes based on certain scenarios. There are two types of conditional structures, if and case statements. Let's look at if statements first. The if statement determines which statements to execute based on the result of a Boolean expression, which evaluates to either true or false. The if statement has three forms. If then, the simplest form of if, it only tests for one condition. If then else has an else statement that lets you specify an alternative set of processes or a default that will be executed if the condition is not true. If then else if, which provides a convenient method of checking several conditions in turn. The if conditions are tested successfully until the first one that is true is found. The if statement forms have similar structure in its syntax and only differs in its number of additional lines that are added for testing other conditions. So, for an if then else if statement, the syntax is if condition 1, then, next line, statement 1, if space condition 1 space then, next line, statement 1, semicolon, next line, else if space condition 2 space then, next line, statement 2, next line, else if space condition underscore n space then, next line, statement underscore n, semicolon, next line, else, next line, else dash statement, semicolon, next line, end space if, semicolon. Each condition is a Boolean expression. When found true, the corresponding statement will be executed. If none of the listed conditions are true, the else statement will be executed. Do note that the keyword else if can also be written as ELSE if. Let's look at how we can apply an if then else if statement to the example scenario of checking sales from earlier. Do space $, next line, declare, next line, sales space double space precision space colon equals space 0.00 semicolon. Next line, KPI space double space precision space colon equals space 100,000.00 semicolon. Next line, begin, next line, select space sum open brackets total close brackets space into space sales space from space supermarket underscore sales semicolon. Next line, if space sales space less than space KPI space then, next line, raise space notice space single quotes sales space R space below space KPI space colon space percent sign close single quotes comma space sales semicolon. Next line. Else if space sales space equals space KPI space then, next line, raise space notice space open single quotes sales space reached space the space exact space KPI space colon space percent sign close single quotes comma space sales semicolon. Next line, else, next line, raise space notice space open single quotes sales space exceeds space KPI space colon space percent sign close single quotes comma space sales colon next line end space if semicolon next line end space $$ semicolon. In this new code block, we've declared two variables first, sales that is defaulted with 0 and KPI which holds the value 100,000. In the begin section of the code, we place the total value from the supermarket table into the sales variable so we can easily compare it to the KPI. Then we started the if statement. The first condition tests if the sales is less than KPI, while the second condition tests if sales is exactly equal to the KPI value. If the value does not meet any of the conditions, we will display the default output, sales exceed KPI. Run the code to show the output. As we can see from the messages window, it states sales exceeds KPI space colon space 32296.74900000007. The case statement selects a when section to execute from a list of when sections based on a condition. Case has two forms: simple case statement, which provides conditional execution based on equality of operands, search case statement, which provides conditional execution based on truth of Boolean expressions. So, if you're going to test using specific values only, a simple case should fit your need. But if you have a complicated condition, it is better to use a search case statement. If we are going to convert the sales if-else-if statement into a search case statement, the code block would be do space $, next line, declare, next line, sales space double space precision space colon equals space 0.00 semicolon, next line, KPI space double space precision space colon equals space 1000000.00 semicolon, next line, begin, next line, select space sum open brackets total close brackets space into space sales space from space supermarket underscore sales semicolon, next line, case, next line, when space sales space less than sign space KPI space then, next line, raise space notice space open single quotes sales space R space below space KPI space colon space percent sign close single quotes comma space sales semicolon. Next line, when space sales space equals sign space KPI space then, next line, raise space notice space open single quotes sales space reached space the space exact space KPI space colon space percent sign close single quotes comma space sales semicolon, next line, else next line, raise space notice space, open single quotes, sales space exceeds space KPI space colon space percent sign, close single quotes, comma, space sales, semicolon, next line, end space case, semicolon, next line, end space $, semicolon. If we run this code block, the same message will be shown. Loop defines an unconditional loop that is repeated indefinitely until terminated by an exit or a return statement. Loops are used to repeat a number of different ways to achieve tasks, and through the use of repetition, you can greatly expand the functionality of a PL/PG SQL function. PL/PG SQL implements 3 iterative loops. Basic loop. This uses the keyword loop to create an unconditional loop within a function. The basic job of an unconditional loop is to execute the statements within its body until it reaches an exit statement. While loop, used to do the job repeatedly within the block of statements until the condition mentioned becomes false. In this type of loop, the condition mentioned will be executed first before the statement block is executed. For loop, used to repeat a specific statement or statements within a block over a range of specified terms. Let's create a simple for loop that will display the numbers 1 up to 10. Type in do space $, next line, begin, next line, for space counter, space in, space 1, period 10, space loop, next line, raise space notice, space, open single quotes, loop, space counter, colon, space, percent sign, close single quotes, comma, space counter, semicolon. Next line, end space loop, semicolon, next line, end semicolon, space $. In this code, the for loop created an integer variable called counter that is accessible inside the loop only. The loop, by default, adds a step to the counter unless you use the reverse keyword, which subtracts instead of adding steps. The 1, period 10 indicates the lower and upper bound of the integer range, which the for loop evaluates before entering a loop. You can also insert a by step if you want to increment by a specific amount. The for loop will continuously run the raise notice statement until it reaches the last number, which is 10. Run the code to view the output. The messages window shows 10 messages of loop counter colon space number from 1 up to 10 since the code looped 10 times. In this exercise, we will do a simple select query with predicates and case expressions. This exercise will teach you how to filter the data using predicates. And we will do a simple transformation of data. We will use the sales from the Superstore dataset. Here are the requirements. Get all the records in 2017, where category is furniture and segment is corporate and home office. Then derive the field profit if it is an even, gain, or a loss. Let's start. Go to PG Admin. First, we will select all columns and filter the records by order date. Type in select space asterisk space from space Superstore underscore sales space where space order underscore date space between space open single quotes 2017-01-01 close single quotes space and space open single quotes 2017-12-31 close single quotes. Then run the query. Now we will get all the records from 2017 with 3,312 records. Let's proceed with the next requirement, which is filtering the records with category is furniture. On the query, at the end of the query, type in and space category space equals space open single quotes furniture close single quotes. Then run the query again. Notice that the records were reduced to 686 rows since we added a criteria category, which is furniture. Moving on to the next requirement, which is segment, is corporate and home office. And we will do this using the in operator. At the end of the query, type in and space segment space in space open brackets, open single quotes, corporate, close single quotes, comma, open single quotes, home space office, close single quotes, close brackets. Then run the query. We now have 334 records. All the filter criteria have been added. The last thing to do now is to add the derived field. On the current query, after the asterisk, type in comma, space case, space when, space profit, space equals, space 0, space then, space, open single quotes, even, close single quotes, space when, space profit, space is greater than 0, space then, space, open single quotes, gain, close single quotes, space else, space, open single quotes, loss, close single quotes, space end. Then run the query. As you can see in the results grid, we have now added a new field which returns even, gain, or loss depending on the profit field's value. Create a concatenated book underscore ID for the landslide table composed of row underscore ID, country underscore code, date changed to the format DDMMYYYY, uppercase first letter of landslide underscore size. Display the book underscore ID along with the other columns, but show only the records that have the trigger tropical space cyclone. In a new query tool, type in select space row underscore ID pipe space country underscore code space pipe 2 underscore char open brackets date comma space single quotes DDMMYYYY close single quotes pipe space pipe upper open brackets left open brackets landslide underscore size comma 1 close brackets space as space book underscore ID comma space asterisk space from space landslide next line from space landslide next line where space trigger equals open single quotes tropical space cyclone close single quotes. To apply concatenation in this script, we've used the double pipe method, but you can also opt for the concat function and use comma between each string expression. The only column which needs to be converted before concatenating is the date. We've used to underscore char function to explicitly convert the date column into a string with the format DDMMYYY. For the landslide size, we've applied two string functions. The left function was applied initially to get the first character, then followed by the upper function to convert it to the uppercase. To filter the record show, we've used the where clause and specified tropical cyclone as the search string. Upon running the script, you should have a total of 88 records with the book underscore ID as the first column. Exercise 3. Apply an inner join between the retail underscore transaction, retail underscore customer, and retail underscore products table. Join on customer underscore ID and cat underscore code. Then display the sum of total underscore AMT by cat field, then sort in descending order based on total underscore AMT. The script for this exercise is select space sum, open brackets, total underscore AMT, close brackets, comma, cat. Next line, from space retail underscore transaction, space capital T. Next line, inner space join space retail underscore customer space C space on space T period customer underscore ID equals C period customer underscore ID. Next line, inner space join space retail underscore products space P space on space T period cat underscore code equals P period cat underscore code. Next line, group space by space cat space order space by space sum open brackets total underscore AMT close brackets space DESC. We used two inner joins in this query. The first one joins between retail underscore transaction and retail underscore customer, which are optionally aliased as T and C respectively. This join uses the customer underscore ID as the join field for both tables. On the other hand, the second inner join takes the data from retail underscore product using cat underscore code in order to display the category or cat field. Finally, we use the group by clause to group it by cat, and the order by clause to display the data in descending order. It is also important to note that you should specify the two fields to display in the select clause so as to hide the rest of the columns. Upon running the script, you should have 6 rows in the output with books as the first category. Thank you all for joining me on this SQL journey. In it, we learned about structural query language, SQL, which is a programming language for storing and processing information in a relational database. SQL statements can be used to store, update, remove, search, and retrieve information from the database. You can also use SQL to maintain and optimize database performances. If you do have any additional questions, please feel free to reach out to me. And once again, thank you for your time.